Okay, this is a little video to go through what is meant by moles, okay? In chemistry, moles is basically a unit of measurement. So moles is a way of scientists measuring the amount of material, the amount of matter that exists. Atoms are very small to count. This is a way for us to manage that information, okay? The definition, a mole, if we have 1 mole, we say that we have got 1 mole of substance, it contains 6.02 times 10 to the 23 particles inside it. So 1 mole of a substance contains this many particles inside it. And this number, the 6.023, is referred to as Avogadro's constant. Okay, so Avogadro's constant. So this is a very important number. It means we don't have to count. It would take us a long time to count this many particles. But if we know that it's a mole, therefore we know that it's how many particles it contains, we're able to use this as a way of dealing with this type of situation. In terms of mass, how heavy is a mole? Well, if we're talking about an element, so for an element in the periodic table, we say its mass is equal to the relative atomic mass for that element. Okay, so for example, if we had 1 mole of lithium, so here's my pile of lithium, I know that this, because it's 1 mole, it's going to contain 6.02 times 10 to the 23 particles. In this case, these particles are atoms inside there. And because when we look at the periodic table, we know this is 7,3. Therefore, the relative atomic mass is 7. Therefore, this has a mass of 7 grams. So 1 mole of lithium has a mass of 7 grams and it contains 6.02 times 10 to the 23 particles. If we had a look at another example, let's pick on magnesium. So if I've got 1 mole of magnesium, then there's my magnesium. I know it contains 6.02 times 10 to 23 atoms. So 6.02 times 10 to the 23 atoms are inside there. And I know from looking at the periodic table, this is 2412. So this has a mass of 24 grams. And again, it is 1 mole. So 1 mole of lithium has a mass of 7 grams. 1 mole of magnesium has a mass of 24 grams. You can use this to scale things up. For example, if I've got 1 mole of, if I use my magnesium, I know that that contains this many particles or atoms because it's an element, and I know it's going to have a mass of 24 grams. Let's say that somebody comes along and they give me 2 moles of magnesium. How do I work out how many atoms there are inside there, and how do I work out the mass of that sample? A little minute to think, a few seconds to think about that. And what I've got to do, hopefully you've recognised, is because this is now 2, I'm going to go, it's 2 times 6.02 times 10 to the 23. If I work that out, so I'm doubling it because this is double, if I work that out, I'm getting an answer of 1.204 times 10 to the 24 atoms. And same logic, because this is 1 mole is 24, 2 moles is going to become 48 grams. So we double this up. Let's say, a little tricky one, let's say I have got 0.5 moles of magnesium, so I've got a bit less now than I started with. Then all I've got to do, if 1 mole is 6.2, I've got half a mole, I've got to take half this amount. So it's going to be 0.5 times 6.02 times 10 to the 23. So I'm taking half that amount, and half that amount is going to be 3.01 times 10 to the 24 atoms. Because it's half, 0.5 moles, it's going to weigh half the amount of this. So the mass of this is going to be 12 grams. So if you've got an element, let's just run through that again. 1 mole of any element, the mass is equal to the relative atomic mass. 1 mole always contains 6.02 times 10 to the 23. This is Avogadro's constant. This is very important. And we can use that, as we've done here, to say, okay, I've gone from 1 mole to 2 mole, so I've doubled this, therefore I double this, and therefore I double this. Whereas in the other example we've got on here, I've gone from 1 mole to 0.5 moles, so in effect I've divided by 2, I've halved it, which means to go from here to here, you've got to divide by 2, and then to go from the mass round there to there, I have got to divide by 2. Okay, so we've got to divide by 2 to get the mass working as well. This is all related by a very, very important triangle in chemistry, and the triangle is this. The triangle says that the number of moles, mass of 1 mole. So there is my triangle. So where do you use this triangle? If I want to find the number of moles, I cover that over. Number of moles is the mass divided by the mass 1 mole. If I want to find the mass, cover it over. Number of moles times by the mass of 1 mole. If I want to find the mass 1 mole, I take the mass and I divide it by the number of moles. So this triangle allows me to manipulate any of these calculations in order to find mass, number of moles, or mass 1 mole. This is important you remember. So please, please, please take some time, learn this, pin it up on a wall somewhere, keep looking at it, get it into your memory so you're able to recall it in an exam situation. Let's have a look for compounds, because if we've got a compound, we've got a little bit of an extra level to think about. Anything is 1 mole is this many particles, 6.02 times 10 to 23, Avogadro's constant. When we talk about the mass of a compound, so 1 mole for a compound is equal to the relative formula mass of the compound. Okay, so the relative formula mass of the compound in grams is the mass. What does that mean? Let me show you what that means. If we had 1 mole of water, H2O, okay, so here is my H2O, I've got 1 mole of it. Because I've got a compound in here that contains a number of different elements, what I've now got to do is calculate the relative formula mass. So to do that, I take my hydrogen, and there's 2 of them. I take my oxygen, there's 1. I've got 1 times 2. I have got oxygen is 16 times 1. Work that out, that's 2, that's 16. The answer is 18, so that's 16. Let's just write that there for you, 16, so the answer is 18. So I've got a mass here of 18 grams, so 1 mole of water is a mass of 18 grams, and it still contains 6.02 times 10 to the 23, but this time they are molecules. So it contains this many molecules of water inside there. Let's do another one, just as an example. Let's this time pick 1 mole of carbon dioxide. So there is my carbon dioxide. And if I've got 1 mole of carbon dioxide, I've got to, again, it's not on the periodic table, I've got to work this out. So I've got carbon, there's 1 of them, which is 12 times 1, which is 12. Oxygen, there are 2 of them, which is 16 times 2, which is 32. Add them together, 44. So this has got a mass of 44 grams, and it still contains 6.02 times 10 to the 23 molecules of carbon dioxide inside it. Okay, let's move this on. Just check the idea about these ratios. So we know that 1 mole of any substance is, for an atom, is equal to the relative atomic mass. If it's a compound, then we've got to work out the relative formula mass, and this is what we've been doing here. Let's have a look then at the idea of the ratio. So if I just push that up there, out the way. So in this example here, let's have 1 mole of, and let's use our water again from our previous work. So 1 mole of water. We know that 1 mole of water contains 6.02 times 10 to the 23 molecules of water. And we know that water has a mass a relative formula mass of 18, therefore the mass of 1 mole is 18 grams. If I was to have 2 moles of water, that would give me 2 lots of Avogadro's constant, so it's 2 lots of that many molecules, which is going to be 1.204 times 10 to the 24, and that is going to equal 18 doubled up, because it's 2 moles, is going to equal 36 grams of water. If I had 0.5 moles of H2O, then what I've got to do here, this is 1 mole, half a mole is going to be half that amount, so it's 0.5 times by 6.02 times 10 to the 23, which is going to be 3.01 times 10 to the 23 molecules of water, and the mass of that, the 1 mole is a mass of 18, half a mole therefore is going to have a mass of 9 grams. So just to remind you, 1 mole to 2 moles we double, therefore we have to double this number, and we have to double this number. If we then look at this bit as an example, you got 0.5 moles, therefore this is dividing by 2. To get from there to there, you divide by 2, and to get from there all the way around to there is also dividing by 2. Okay? There's going to be other videos later on that are going to show you how to use the triangle that we were talking about here earlier, and we're going to show you some examples of how to use this triangle in order to do some of these calculations that we've got. Okay, thank you very much for listening.